Hey everyone, welcome to today's video. Many engineers know the TCP handshake as SYN SYN-ACK ACK, three-way handshake, three-step, simple, right? But here is the problem. In production, you don't see these diagrams. You see requests are hanging, connections are getting timed out, and at that moment, no one literally thinks about the SYN packets. Today, I want to show you something different, not how the handshake really works, but what it actually looks like when something goes wrong in a production environment. By the end of this video, you will understand how this small handshake plays a key role in real production outages and how you can use those signals to debug to the actual problems. So without any further delay, let's jump into the topic. So today we will divide this video into multiple steps. The first step, we will try to understand a scenario in which you will get a problem and how you can use TCP handshake to troubleshoot. Then secondly, we will try to visualize how handshake gives us signal during production outages or in a particular problem and how you can carve out meaningful information from those signals. Thirdly, we will try to understand when does this actually happens and what are the common scenarios in which these circumstances can occur and how TCP handshake can help us debugging that. And finally, we will try to connect all the dots and we will try to connect all the signals which we have received, and we will try to understand or we'll get into the root cause about the problem. So let's see it in action. Let's assume this is my server and in this I have some application which is running, and I want to understand what exactly happening under the hood. To look what exactly is happening or whether my application is running or not, I can do HTTP request to the local host followed by the port wherever my application is running. For now, my application is in dead state. I have not started it yet. So I will just hit a curl command and I can see the connection is being failed. So we have understood in our previous videos or else in other TCP videos that handshake helps us to establish the connection and understand whether the connection is happening or not. If the connection is not there, then the handshake is broken and there is no communication between your client and your server. So that is the same scenario we are seeing. We are trying to curl the endpoint where our application is running, but we are not getting it in signal. How it is getting visualized in handshakes? Let's try to see it. To see it, we try to run some command as TCP dump. So TCP dump is a command which helps us to show all the handshake signals which is happening under the hood, and you can filter it out using the port which you want to see from this command, something like this, and you can hit enter and you can see. It will not store any real-time logs, but it will show you whenever you are doing any connection requests or any applications or any client around the world who are fetching or trying to access the application in real time. It will try to show what exactly it is happening at the TCP layer. So let me run the curl command again. Now I can't reach it. Let's see what it has given. Now I can see there are some messages in my TCP dump output, and let's see what it is. Here I can see there are total 4 requests which has gone. First, it is this, and here I don't have to explicitly understand everything as a production engineer or a first time engineer or as an incident coordinator or whoever. What we need to understand is we need to carve out the signal which is important for our problem or about our troubleshooting. What are these? I can see there is a flag which is S, then again there is a flag which is R, then again S, and again R. These are the very important thing. So you don't see directly SYN SYN-ACK ACK signals, but it is being visualized in the form of this flag. So whenever you see the first flag as S, it means it has given a SYN signal, which is our first step of our handshake. It has tried to establish a connection and by sending a SYN request. And after that, it has received a R dot, which means it has not got any acknowledgement. So that is why it has terminated. So R dot means it has terminated the request. Don't worry about this flags. I will give you a cheat sheet which you can use it for your reference or for future references, or else you can just Google it. You will get it. But for your reference, I will give you in the description. You can find it. So now again, it has sent a S request and again it has got a R dot, which means it has terminated. But now you might be asking why we have got the 4 outputs, but we are just giving one signal, right? So if it has not got any signal or it has not got any acknowledgement, and it should have terminated, it should have 2 output only. Why it is 4? Here, TCP does something interesting is that whenever TCP tries to connect to an application or from a client to a server, it doesn't go in a one interface. It tries to use multiple interface, which is possible. Now, here what I can see is there is one connection request which has gone on IP6 and one more in IP. IP means it is IPv4. So TCP will try all possible connections which it can, and wherever it is getting the acknowledgement, it will try to transmit the messages or it will try to send the connection request accordingly. So it first tried with IPv6, it didn't get it, for which it has rejected or terminated. Again, it tried for IPv4. Again, also it didn't get. Again, it terminated. So resulting to which now my application is dead. What I will do is I will start my application so that I will see again how it is looking in real time. So let me start my application and let me hit the curl again. I was not getting any output. I was getting timeout or could not connect to the server. And now I can see the output. Let's see what is happening under the hood for TCP dump. Now our requests were ended over here. Now these are the new output in the TCP dump. Let's try to understand. So here again it has sent S and which is nothing but a SYN request. Then it has got S dot, which means SYN plus ACK, which means your connection has started and your server has accepted your request. Then again it has given a dot, which means it has again a acknowledgement. SYN SYN-ACK dot or ACK. Now the three-way handshake is now getting established. Now it has again started a P dot. P dot means push plus ACK, which means now it will push the HTTP request or HTTP output, whichever is looking. Now data gets transmitted. Then again, it will get a dot, which means now it is working. Then it will continue the connection. So this is a classic example of a connection, how exactly it looks under the hood when a three-way handshake is getting performed. Now I can be assured that my application is working and the handshake is perfectly working. And you can visualize the three-way handshake from this output. If you are not understanding or any doubts, please let me know your thoughts in the comment box. I can do more videos on this so that you can understand or find it interesting whenever next time you are getting into an incident. So now let's get into a real-time problem. Let's create a problem for us. What I have done is now I have created a artificial delay to my application for which my requests will land little bit delayed. Right. So this is my scenario, and this is the actual problem which might face in your production environment as well. For example, your users can complain that they are getting connection timeouts or their application is not responding over time. It is taking too much time, more than expected time. Or some people may say that they are not having any issues. Application is working perfectly fine. It is a kind of a confusing issue, right? You go get into the server, you try to check the logs, you try to check the utilization, you find everything is working fine. Then what you do? Then most of the time people try to understand that most of the time if application is slow or API is not responding or giving timeouts, then they think that there is something happening or at the hardware level or at the system level or at the resource level. They forget about the TCP layer or at the networking layer, which is the minimal block or the starting block of your networking. That is where we try to get into the actual problem. So whenever you get complaint about slowness or timeouts or your connections are short-lived during that time, the first thing which you should look is your handshake process, how exactly it is working, whether it is doing any congestion or not, whether it is landing slowly or not. Those things or those questions you should ask to yourself, and you should get into your TCP layer to track down the handshake process, and you should carve out meaningful information so that you can reach to the actual problem. Let's see how in our scenario it is exactly behaving and how actually it is giving us the signals to find out what is the real cause. Let me hit my application using a curl. Here I can see previously it was giving me instant result, but it was fast. Now it gave me a little bit slowly. That is the first signal which I got it. Now, what I will do is I will again go to my TCP layer or to my TCP dump output, what is happening. Now, I know that there is no signal on IPv6 because previously I was not getting any output at the IPv6 because applications is serving traffic on IPv4. So looking into the IPv6 output is literally noisy, and you cannot get instant responses out of it. So for achieving that, what we do is we try to tweak the TCP dump command as we like, and we can use it accordingly. So for my case, what I do is I use the TCP dump with this flag, something like this, where I try to filter out the port 8080 and we see the TCP flags only, and we look for the SYN signals out of it. This is a flag, and you don't have to memorize this particular command. You can use your own command. I like this and it suits my use case, so that's why I have used it. If you are not able to memorize, I always say write it down somewhere. Whenever you are getting into an incident, you can use those commands frequently, so that you can get meaningful information, right? So now I have run this command to reduce the noise little bit from my TCP dump output. I will again do a curl command, and let me see the TCP dump. Now I can see there are some output which is coming, and let me see whether it has finished or not. Yes, it has finished now. I saw that it took a little bit time to give me curl output itself. Now let's see what is happening at the TCP dump layer. So now I can see first it has given a SYN signal, then it has got an SYN and ACK. Again, it has tried for a SYN signal, and again it has got a SYN ACK. But there is no acknowledgement which it has received from the client to the server for further processing the information or further pushing the HTTP page which you are looking for, right? Because previously we used to get a P dot, now we are not getting that. In this, you should not carve out the information as that application is not functioning. Application is functioning, but there is a slight delay or there is a congestion during the push or during the push phase which is happening. The three-way handshake is taking little bit time or more than required time, for which that step is not getting executed. That is one way of information. That is our second observation. Third observation, what you can do is at the left hand side corner, every packet which it has sent, you can see the actual time it has taken. For the SYN signal, for the first signal to go, it started at 32nd second and it got the SYN ACK at 0.33 second, which means there was literally 1 second of delay for the handshake to happen or the round trip to happen, for which it has delayed the signal. So whenever this delay happens, TCP will automatically terminate the connections so that it doesn't completely fulfill the three-way handshake. It stops at the second step itself. So that is what it is happening. And this pattern you can always understand when you see more and more outputs, and you will clearly understand that when this S dot and S dot is happening, there is this pattern means that there is a slow start which is happening, and you can understand that there is some slowness in my server, right? So this is one way of achieving it. Now we have understood that there is a congestion in my TCP layer and something is happening at the network layer which is creating this delay. The next question is when exactly this can happen, right? Or what are the other circumstances it can happen? I have created an artificial congestion to my application response for which I am seeing this. But in production environment, when this can happen. So it can happen whenever your traffic is spiking. For example, you have Amazon.com and normally it is receiving some users, X amount of users in normal day. Let's say Big Billion Day is getting started and suddenly it has seen the spike in traffic. Maybe from 1 million, it has gone up to 50 million or 100 million requests, which is arriving per second. During that time, more packets will arrive. And during that time, there is a high chance of packet drop and there will be slowness in your application. That is one scenario. Second scenario can be you have the cross region communication. For example, you have your clients in Africa, but your servers are in US. There are cross region communication which is happening, or your application server is in Dallas, or your database is in, let's say, in Atlanta, or for example, multiple regions, right? So if you have this kind of multi-region communications, so there is a higher latency chances and there will be more retries which is happening, and it can amplify your delays within your application. That is, can be your second scenario. There can be a third scenario where you will be having load balancer in between your backends. Your request or packets can go with multiple hops. During that time, you can also see a delay within your application, because more hops means more delay or maybe a drop in your request as well. That time also it can happen. Lastly, you can have short-lived connections where, for example, if your system is consistently creating new connections and you are repeating this handshake again and again, so whenever there will be a small instability, it will be clearly visible in the TCP dump itself. So whenever you are having short-lived connections, that time also it can happen. And this kind of scenarios are not rare, and this happens quite often. And in most of the systems, it's a very common problem. As a production engineer or as a reliability engineer or any normal engineer also, you should see to your TCP handshake procedure how exactly your packets are getting transmitted, and you can do in this way to understand how exactly your application is serving the packets. Now let's connect the dots to our actual problem. So in our problem, what exactly was happening? Your curl was behaving slow, but application was running fine, but it was slow. So what was happening? From the TCP dumps we saw, the SYN were getting sent, there was no response, it was again retrying, and finally it was getting connected. Now imagine this at a scaled situation or in a scaled environment. Not one request which will be getting into your application. It may be thousands, it may be millions, or it can be billions requests which can land per second, right? Some connection or some request will be landing instantly, and sometimes it is fast, but sometimes it is slow, or sometimes it is just not landing, right? So that is when you will see the latency drop, or you might be seeing that slow systems, or you are just unable to reproduce these scenarios within your environment. So that is when your signals from your TCP dump or from your three-way handshakes make sense to track down this actual problem whenever you are getting into this problem. Now, what are the other tools you can use? So most of the time, engineers, for this kind of latency issues or this kind of slowness issues, they use tools like ping, traceroute, DNS lookup, or they can use dig command, so and so. So ping will tell you host is reachable or not, but it will not tell you that whether your application is accepting any connections or not. Traceroute will show you the path of the packets are taking, but it will not show you whether a connection was actually established or not. Dig will show you that your DNS is working or not, but it will not show you whether your service is reachable over TCP or not, right? So these are the tools which are very useful. I'm not denying that, but TCP handshake output or TCP dump will tell you whether whether your communication is actually happening or not. If it is happening, how it is happening, how much time it is taking, all this information in very detail. So that is why it is very powerful and we use it in a regular interval of time. Now, enough talking. Let's see how you can exactly debug this issue whenever in a real system it is happening. So as I mentioned, these problems are not reproducible most of the time, but you can use some measure or you can take some measures to drill down to the actual problem. So what we do is we try to run a command before curl, which is time, and we try to hit our port, and we try to track down how much exactly time it is taking for reaching to the connection. So here you can see in real time, it is almost taking 4.2 seconds, which is high connection time, which means you can carve out there is a handshake issue. And if there is a high transfer time, you can understand that there is an application issue. In here, you can see in real time, it is connection time is more, and you can understand that there is something at the TCP level. Now you can see the TCP dump output. That is our second scenario. Observe the TCP. Thirdly, what you can do is you can run it multiple times to track down whether it is actually happening for a longer period of time or it is just happening temporarily. So because most of the time what happens whenever you are having a TCP drop in packets, it kind of a intermittent, right? Because if, as I mentioned, if you have sudden spike in network or there is a network congestion is happening for whatsoever reason, if it is happening, you can try it out multiple times. If it is happening, then you can see other signals like looking into networking devices, networking outputs, your VPCs, your other issues, whatever it can be at the network level, you can check. But if it is continuously happening, if it is not continuously happening, then you can understand that it is just a intermittent issue. Is it really impactful? Can this cause a real incident? The answer is yes, absolutely. How? If your retries delays are going more and more, or your traffic is increasing more and more, and your latency is suddenly spiking, during that time you will see more timeouts, you will see more retries, you will see sudden latency spikes within your monitoring systems, and you start receiving more and more user complaints. During that time, this can convert into a real production incident, and there is no limit of how severe it can become. But to start with, you always see the signals and you try to carve out how exactly your three-way handshake is happening and how much time it is taking, right? So that is the first day of troubleshooting whenever you receive any connection timeouts or latency issue in your applications. At a final note, I can say the TCP handshake is just not a concept, it is a phase. And if that phase is unstable, everything above it becomes unpredictable. You cannot control what can cause and what things it can bring to your overall system. And you should carve out this particular signals very carefully before it goes bad. So with that, we end today's video. If this video has given you a clearer picture of how exactly three-way handshake behaves and how you can track down your three-way handshake procedure within your system, then please hit that like button and do subscribe to our channel. If you like this kind of videos and you want to see more in future, please subscribe to our channel and let us know your thoughts and feedbacks in your comment box. We love to hear your thoughts on our videos. And with that, thanks for watching. See you in next one.